Good morning all. I am Subramanian, pursuing my MA in CSE, Technological College of Engineering, Madurai. And I am here to present my paper, Design and Evaluation of a Hybrid Hierarchical Feature Tree Based Authorship Inference Technique. Before going to the explanation of the paper, I will say the importance of authorship inference. India is nowadays becoming digital by Modi government. But previously and still now we have many papers to deal with, and for example many court disputes have paper as evidences, and especially we need the evidence as author who has written the paper, especially a letter written by a particular person. In case of historical monuments, we mean some person come and claim that this particular historical writing is written by me. Since we don't know the author who has written it, we solely accept them if he or she is an authority. To avoid this, I am going to do a project on authorship identification and verification. This project takes as input a set of samples D1, D2 and DM named, and a set of writers, the corresponding writers of those samples. And I ensure a function psi which says that each document is written by a single writer, and consequently, and no two writers have written a single document. This will be very useful when we say the writer of a particular document is a particular person and not more than one person. And our task is to build a model theta that accepts the set of handwritten samples along with its known writers and the mapping function psi. When the test sample is given as input to that model, it will return the writer of that sample. And the methodology is this, and it will take the set of samples as input initially. The methodology is named at HHFTAI, Hybrid Hierarchical Feature Tree Based Authorship Inference. It is named as hybrid feature tree because it uses three feature extraction techniques, namely half-circle transforms, vertical length of black pixels, and finally speeded up the best features. This is named as hierarchical feature tree because it will construct a tree by using these three feature extraction techniques. Initially, the whole set of samples will be subjected to half-circle transforms. When half-circles transform is acted on these samples one by one, it will return the number of circles in that sample. Based on the number of circles, each of those samples will be placed in a particular class by the function k is equal to num circles by I. While I is the static value we keep by trial and error method to place the particular sample in the particular class k. This I is chosen just in such a way that if the largest number of circles in a particular sample is 300, then we place I as 50, so that the samples which are circles from 0 to 50 will be placed in class C0, from 51 to 100 will be placed in class C1, and so on. Then for each of those classes constructed out of half circle transform, then for each of the samples in those classes we use vertical length of black pixel feature extractor. This feature extractor, based on the value lambda, will separate the class into two further classes. These classes will construct our samples that is either larger or smaller than the threshold lambda. For the leaves, speeded up robust feature extractor is acted upon and the value is kept. And now we have the hybrid feature tree. This hybrid feature tree is the result of the training phase. When a new sample whose writer is not known is entered into this sample, into this tree, it will first be kept in the root. In the next level, there are a number of classes. This test sample dt will be placed in one of the sample when it is acted upon by half circles. If its half circle is around 105, then it will be placed in class C2. From the class C2, the vertical length of black pixel feature extractor will be used there, and based on that it will be placed either in C21 or C22. Finally, it will be acted upon by surf. Now we have a test sample together with the number of samples already there in that particular class from the training phase. Now we use the nearest neighbor criterion in order to find the nearest matching sample with the test sample among these training samples. If a particular training sample matches with this test sample dt, then the corresponding writer of the training sample will be written as the writer of the test sample. And this is the algorithm. This algorithm in for author will take as input the d comma w, the sample, along with this writer, together with the bijective function psi and the test sample dt, and three feature extraction techniques f1, f2, f3, I the threshold of f1, lambda the threshold of f2, and the output wt. This function calls three functions again. First, it calls the generate authorship model. It's here. This generate authorship model actually constructs the hybrid hierarchical tree. It will take the whole samples of inputs, and in each level it will be using one of the feature extraction techniques. In the first level, it uses half circle transform and split them into number of classes, each class containing a set of samples, satisfying the condition to be placed in that class. In level 2, the vertical length of black pixel is used, and in level 3, surf is used. In extract feature descriptor function, it takes as input the constructed model theta together with the test sample. Here the test sample will be acted upon by half circle transform, then vertical length of black pixel, and finally surf. Based on that, this test sample will finally reach a particular leaf node where there already some set samples are there, and this dt is also there. In the predict author function, this test sample together with the samples will be used as input, and the nearest neighbor criterion having Euclidean distance measure will be used to identify the nearest sample closer to the test sample. When the nearest sample is found, the corresponding author of the test the training sample will be written as the writer of the test sample. If none of them match, then we return that none of the training samples match with the nearest matches nearly to the test sample, and we return pi. And this is the explanation of the algorithm. And I say that the half circle transform, vertical length of black pixel, and the speed of global features are used as feature extraction techniques. These came from the basics of graphology. When you look at some handwritten documents, you recognize the difference between two handwritten documents by thinking about the height of the characters, space between the characters, length of the characters, and so on. And this is the same meant here technically. Half circle transforms identify circles in the handwritten characters. If it returns more number of circles, then it means that there is more spaces between the characters. The author is writing the characters by leaving more spaces in between them. And also it means that the author is writing the letters more large. And this is actually a unique feature characterizing the particular writer of the handwritten sample. Hence, half circle transform is used in the first level of the hybrid tree. In the next level, vertical length of black pixel is used. It is used to measure the height of the characters used by the authors. If the author writes above 125 pixels, which is meant by statically, we mean that the author writes larger, and if it is less than 125, we mean that the author writes smaller. Finally, surf, the object detection technique is used. I will say why an object detection technique is used in an authorship inference technique. First, I will say how surf works. Surf initially captures the interest points using Harris corner detector. From the input image, interest points are captured using Harris corner detection algorithm. Interest points are those points in the image which by slight displacement produce more distinguishing effects on that image. Those interest points are also called key points, hence surf is also called key point descriptor. These key points are measured at varying scales and normalized using Gaussian normal function, and an Hessian matrix is constructed which makes surf a scale invariant function. Hall values are used to describe these interest points. These interest points are the number of nearest matching points are be a scalar value which is used to say that a two image is matching or not. Finally, we have the test sample along with some samples. We actually construct a big tree, and to reduce the number of samples, initially there are around 100 samples, and when we and the number of samples should be compared with DT is only 10 finally. So hence we reduce the number of samples into a small value even if we start with a large number of samples. This is very efficient and effective. Finally, nearest neighbor algorithm is used, which uses Euclidean distance measure to find the nearest sample, and the corresponding author will be written as the writer of the handwritten document in question. The databases we use are IAM handwritten database, a standard database for authorship identification and verification; serial database, another standard database in English and German for authorship identification and verification. We also use a self-curated handwritten database in Tamil, which we have constructed using 56 writers, each contributed 2 samples. And the tool we used is our open source computer vision developed by Intel. It is an open source tool for image processing and computer vision, and we use Python for it. And we also developed a user interface for our desktop application, and we use tkinter for the user interface, and the whole application is developed in Linux Ubuntu environment. And surf and object detection technique, why it is used in authorship inference. Now in figure 1 you see the picture move. This is a word from IAM database, and surf has identified number of key points in that move. These key points depict an interest point or the distinguishable point for that word move from other images. In figure 2 and figure 3 we have some words. In figure 2 there are 2 words written by different writers, but they are same words, labor. Since surface and object detection techniques, it identifies, and also scale invariant, it identifies the match between 2 objects. Both objects are actually labor words, but written by different writers, so the number of matches is actually very less. In figure 3 we have 2 words written by same writer. These are 2 different words actually, but surface identified more match points between them. This means that surf does not deal with the objects blindly, but it deals with the characteristics of the handwriting in the words. Hence, we quote that we didn't read the words, but we actually characterize the words. And the experimental results are, we obtained HHFTAI on IAM dataset and obtained a recognition rate of 97.15%, which is actually a good compared to the existing state of art techniques according to our knowledge. And our recognition rate with CVL dataset is 95.78% at 3000 features. And I explained the graph. Here we have the number of features in the x-axis and the recognition rate at the y-axis, and the T12, T15, T18, T21 and T24 are the thresholds at which the match points are to be compared. T18 refers to that at least 18 match points should be there between the 2 images compared. And HHFTAI on CVL dataset German has achieved a recognition rate of 96.50 with our proposed model. And this is our self-curated and more special dataset Tamil, and achieved a recognition rate larger than other techniques, 97.35%, because we concentrated mainly on Tamil, and we also concentrated on English and German, so say that this model apply universally to all the languages. Currently we deal with Tamil, English and German. And this is the comparison with existing state-of-the-art models. Hanad et al. Used random features such as LBP, LDP and LPQ, local binary patterns, local ternary patterns and local phase quantization techniques to identify an author, and achieved a recognition rate of 89.50 with IAM and 96.20% with CVL. Bertolini and Villacchi used local gradient descriptors and achieved a recognition rate of 96.7 and 89.0 with IAM respectively. Our proposed model achieved a sound recognition rate of 97.15% with IAM and 96.20 with CVL, which according to our knowledge is actually a better recognition rate in comparison with existing state-of-the-art models. As I stated earlier, we also created an user interface for our desktop application, and this user interface consists of a home page with 3 buttons for IAM database, Tamil database and a comparison. This final button is for authorship verification, which takes as input 2 separate documents and checks whether these 2 documents are written by the same writer. These 2 buttons will take a document as input and identify the author of the document. When an IAM database is selected, this page appears and when you click Info Writer, you can select a document from the browsing option, and once you select a document, the corresponding writer name will be displayed. These pictures, next picture, previous picture, I used to see the outputs. We use 3 feature extraction, right? And the outputs of half circle transform, vertical length of black pixels, surf can be viewed by clicking these things. And finally, we conclude that our performance has been evaluated with 2 standard databases, IAM and CVL, and also with a self-curated Tamil handwritten dataset. And it achieves a better recognition rate with Tamil compared to IAM and CVL because we developed especially for Tamil and later extended it to English and German. Also, comparing with other existing techniques such as random features, Arnold transform, local gradient descriptors, our model experiences a better recognition rate with IAM and CVL too. This Arnold transform to be quoted is especially used for cursive handwriting documents, and CVL database is mainly for cursive handwritings, and we achieved a sound recognition rate compared to Arnold transform by using HHFDA. Our future research direction include incorporating some computationally cheaper feature descriptors than half circles, vertical length of black pixels or surf. And an attempt is also made to compute the theoretical time and space complexity bounds of the proposed model. And these are the references we made during our coursework. And finally, thank you. And also I thank you for allowing us to present through video conferencing. Thank you.